and thank you, respective conferences. So, that's the what and the how. I think it's also quite stable knowledge on that field. There should be iterations. Peppers et al. Were already mentioned. They did a survey of all the different procedural models. And at the end, they all have certain phases that they find are important for design research. Hefner once did propose his famous three-cycle view. The core is the design cycle, and there's a relevant cycle and a reader cycle. At the end, if you reflect what you probably did and do in your design research, I'm not sure whether you have 3 cycles. Do you have 3 cycles? Probably not. So I never had 3 cycles, to be honest. We do it a little bit different. Conceptually, you could separate these logical cycles. In fact, how we usually experience our work is more a one-cycle view. And the cycles around the knowledge base and around the problem understanding. And what I find important, which with each iteration, we learn a little bit more from the problem. And with each iteration, we can use additional stuff from the knowledge base. But I don't see 3 main iterations here. There are different aspects that we look at when doing iterations. But at the end, at least in our experience, it's this build and evaluate loop which is informed by the available explanatory and design theoretical knowledge, and which helps us to always better understand the problem in order to be at the end, be able, if we cycle around here, at the end, come up with a useful solution that then finally adds something to the knowledge base. There are different views on this, different experiences, but at the end there is a set of, I would say, 10 papers or so, or 5 to 10 papers that you can reference if you want to do a design research publication, and you don't have to explain every time anew what you're going to do and how you do it. And that's a good thing. That's the benefits of 10 years of design research and published design research in the field. So, what do we do differently or from a different perspective in St. Gallen? We specifically issue this generosity issue. So at the end, when our problem is, for example, to develop a management approach to business intelligence in large companies, or a management approach to performance management, or a management approach to enterprise architecture in large companies, usually our biggest problem is to make it sufficiently generic to cover the diversity of stakeholders, of goals, of successful solutions that we see in the real world. So that was what drove us to look a little bit more into this issue of design factors, design situations, and reusability and configuration of designs. And that's the first part I want to illustrate. And I'm using something that you probably often know and often use. Google Maps, or let's tell Google Maps. So, and our problem is to design a highway intersection. And on the first iteration, all highway intersections in the world look the same. This way. If you look a bit closer, they look like a highway intersection. If you look closer, we see more detail. If you look even closer, we see even more detail. So this is the highway intersection. An instance. This is another highway intersection. Another instance. They look different. Why do they look different? These are design solutions. If we want to understand construction and understand construction genericity, we should understand diversity of the solutions. There are so many solutions in the world that are all somehow different, and serious competitive design should be able to explain these differences. should be able to construct solutions for whatever situational factors. So highway intersection construction engineer, if he wants to publish an MSQ or in his top journals, he should be able to exactly make transparent why this intersection looks this way. So there are many bridges here, that's a 4-level divide, and this here looks different. It has different shapes, it has lesser bridges, it has different radii here for the streets. So this is really very different solutions, and you need to be able to explain the differences in the solutions. It's pretty much the same whether we're talking about highway intersections or enterprise architecture management solutions or performance management artifacts or whatever, in our opinion. So, we need to explain first why the solutions that exist are so different, to be able to re-engineer, if you want to, the rules that govern construction, and then create a kind of design theory that helps us not only to explain existing solutions, but of course then to create new ones and innovative ones. That's what we wanted to achieve. So can we, and now we can talk about intersections, that's nice illustrative, nice photos that you will see. Can we explain all the highway intersections in the world based on a set of construction rules and construction theories? If yes, then we've achieved a big goal, because these rules and foundations then would help us to construct any other new highway intersection according to the requirements. The same is true for all the other things that we see in, at least from a management perspective, information systems design. So, are there archetypes? Are there patterns? Are there explanatory theories that explain why these are different? Are there design theories that help us to find the solution systematically? That's basically what we try to understand. So we try to explain why all these things look so different and why they had been designed this way and not a different way. And of course this is a nice illustration, because we all used to use these artifacts, and it's a little more illustrative than if I would be talking about performance management systems here or about business intelligence organizational patterns. But at the end it's the same, at least in our understanding. So what we try to do is to find some patterns or reference solutions on different levels of abstraction. Like for example an exit pattern, a roundabout pattern, an intersection pattern. Try to understand what are the influential factors to use a roundabout or intersection or an exit. There are patterns, so there are certain requirements that relate to certain solutions, and that's a design theory if we want to understand this design theory to be able to apply it. And we want to identify common components in these solutions that can be reused to configure solutions. And if you're reminded at situational method engineering, yes, that is situational method engineering, but not applied to software development, but applied to solution design, intersections or whatever. So that's situational method engineering. How do we do it? Try to understand what we see in the real world. We see many, many different solutions, and we try to generalize. So at the end, all the intersections are intersections. Then we have different patterns, different sub-patterns, and all the different instantiations. And wouldn't it be nice to understand all the mechanics between these solutions, to be able to see what solutions are closer to each other, are how much related, in which way related, and then discover by that way how to build these solutions. That's exactly what we do. We try to identify what we call design factors, and for roads that's quite clear. Traffic intensity is an important factor, and also the differences in road classes, for example. And if we have found certain design factors, we are able to classify solutions. So if stops are allowed, depending on the traffic intensity, different patterns can be observed. If stops are not allowed because we have high-speed traffic, we see different patterns. And we see that certain combinations don't exist in the real world. So if all directions have low traffic intensity, but they all have high speed, we don't see that. So this is the first step to understand reality, to be able to classify the solutions according to at least suspected influences that we feel are important or that we know are important to understand the diversity. Then we see patterns that you all know. And if we have patterns, we have made the first steps towards what one could call design theories. That we have, for example, certain switching points where we switch from one solution pattern to a different solution pattern. And that's what Van Aken calls the technological rule. That's a means-end relationship. To achieve a certain ends, we make a suggestion for a specific means. And again, it's the same whether we construct intersections or whether we construct EAM approaches. And I will show you. And there's theory, explanatory theory. For example, depending on the speed, you have no free choice of the radius of a road, because cars will just drop out the curve if you have a high-speed road and a too tight radius of the road. So there is rules, there's some kind of natural laws that govern the solution design. And that's pretty much the same in information systems. We also have our natural laws. That's all the stuff that the theory builders identify. That's the explanatory theory. They explain certain things to us. For example, the unified theory of technology acceptance and utilization explains why certain aspects of information systems, or what aspects of information systems explain their use and their acceptance. As these theories here explain what kind of curve radius we can use depending on the desired speed on that lane. So that's the explanatory theory that we need to build into our solutions in order for them to be grounded. Because there will be questions by the reviewers and evaluators. And now comes a big step that is different between explaining things and creating things. And this is valuation. Our solutions are never true. They're hopefully useful. So we need to have an evaluation that comes basically from the stakeholders and that is not present in all this explanatory research. And the stakeholders are not interesting because we are trying to explain something and it's all either true or not true, but it's not subject of evaluation. Here we do designs, and designs are subject of evaluation. So we can, for example, our goal could be either to maximize traffic flow or to minimize traffic flow. And you all know patterns that help to minimize traffic flow. And if you want to slow down traffic, you just do a lot of roundabouts and then everything will be slowed down to some extent. Or if you want to speed up traffic flow, you do other things. And that is valuation. And that's basically a thing that comes into design research that is totally non-existent in explanatory research. And so it's always very important to frame your research and to frame what you do in a specific context. And here this could be some multi-criteria valuation of design patterns that can, for example, then be transformed into decision trees that help us to identify the appropriate pattern for certain goal vectors.